Hello. So in mathematics, the symbols usually mean something specific. Sometimes they don't. You can have X bar would mean one thing in one field of math, something else in a different context with math. We have uh, parentheses mean a variety of things. I mean, this here might be the interval between 1 and 2, not including the endpoints. This may be a point on a graph when x is 1, y is 2. And so, unfortunately, the single symbols don't have to be universal across math. And you might, with this class or some other class, you might come across a problem where you have a B and a B. Well, this is not too difficult to tell that these are not the same B's. One is a capital B and one is a lowercase b for whatever purpose. But what if you have an unusual looking bee like this? This is not quite the same as the other bees, and this type of bee usually behaviors around this bee is not what you would normally see with the other linear problems. This is more of a bigger concept. And it's not just this funny looking B. You can also have an unusual looking A. You have kind of a curly C. And so all of the letters in the alphabet we can write with a different type of notation. And this other type of notation means something else specifically. And this is getting into power sets. So we're not going to be covering power sets in this class, not formally at least. But if you are a STEM major, you very will likely get into abstract algebra. It's a beautiful field of math, but abstract algebra has power sets. Well, what is a power set? Okay, power sets. Google this if you are interested. Watch some YouTube videos. It's kind of an interesting field, but we're not going to get too much of it into this class. The reason why I'm mentioning this is because I'm seeing the Weierstrass notation in the slides, and I figured I would go ahead and explain what that Weierstrass notation is doing. So power sets. In mathematics, the power set of a set S is the set of all subsets of S, including the empty set and the entire set itself. Power sets are often denoted using the Weierstrass alphabet. This is the proper spelling, Weierstrass, and this is named. This is in honor of the gentleman who had expanded this field of set theory. So power sets are often denoted using the Weierstrass alphabet, and the LaTeX command for this is slash mathcal, and then whatever symbol you want to do, make the Weierstrass shape. And so this can be any letter. This can be A, B, C, D, whatever letter that you want to make your Weierstrass become. So let's say we have for example, let A equal 1, 3, and 4. Okay. Say you want to find the power set of A. Okay. Well, this would be shown as that funny looking Weierstrass symbol that's not quite the same as a regular looking letter. So the power set is going to be the empty set. There's nothing. And the braces, when we have braces, this braces just means that we are interested in what's inside. Okay. And so this is the empty set. The empty set is not the same thing as 0. 0 is something, even though it's nothing. Different kind of a concept, the 0 from the empty set. The empty set just means there is nothing there. Not the same as 0. That's a different discussion. Also, we have the single element 1. We have the single element 3. we have the single element 4. These are supposed to be curly braces. I don't draw them very well. And then we also have the set here. We have 1, 3, and we have 1, 4, and we have, make that a brace, and we have 3, 4, and then we have the whole set. So this is the power set of A, denoted with the Weierstrass A, and we have all of the elements, all of the combinations, including the empty set, including the whole set. And so without loss of generality, if we have this regular B here, you want so the B is just regular, it's just a set. To find the power set of B, that's when you would have this unusual looking capital letter, kind of fancy looking with some flair and some curls to it. That's the power set of B. And I'm mentioning that because as we're getting into linear transformations, they're using the power set notation, and they don't exactly explain what it means. They kind of do. We are proving that you are showing everything, but if you just have in the back of your mind that when you have these fancy capital letters, that these are the Weierstrass notations for power sets, which mean the everything. Thank you very much. Please go to tutoring.